Yeah. So here, with this class, car is a parent class, okay, which also inherits from the ABC helper class. And mileage is an abstract method here. Now, this mileage is a compulsory method, and this mileage should be present in every subclass. As you can see, we have three classes: Tesla, Suzuki, Duster, Renault. So we have four classes, and in these four subclasses, we have mileage as a compulsory method here. You can see, because the main class, the car class, is forcing all the subclasses to put this mileage as a compulsory method. If I remove this one, then it is not compulsory to put mileage in the subclasses. But if I put here as a at the rate extract method, then I'm making this particular method a compulsory method to put in every subclasses. And as you can see, there is mileage in every subclass. The same method in every subclass, which contains different mechanism. Like one is printing 30 kilometer per hour, second class is printing 25, third class is printing 24, and fourth is 27. So the main class, we don't have the implementation, the real implementation. We have the real implementation in the subclasses. These are the subclasses, or we can say the child classes. Why?
Mm-hmm.
Because they are all inherits from the main car. Car is a
Mm-hmm.
parent class here. Okay. So now if I run this one, you can see the mileage is 30, 27, 25, and 24. Okay. So this is like a whole concept of abstraction. Okay, again, I just sum up everything. Let's say you are a senior programmer and you have created a banking application. Let's say I'm a junior programmer and I just wanted to use your method, let's say the database method from your class, from your main application. Now you have asked me that you can use my database method, but you have to implement the security as a compulsory method in your subclasses. So that is what we can achieve with the help of abstraction. So in the abstraction, you have implemented a security mechanism here, which is depth security, and you have put a abstract method, which means this method should be compulsion, or we can say compulsory in every subclass, which is security and interface. This is whole abstraction. Abstraction mechanism is forcing the subclasses to put some method. And an abstraction class can contain the normal method, which is database here, a normal method, and the abstract method. And any class which contains the one or more abstract method is known as the abstract class. Okay, so this is the abstract class here.
Mm-hmm.
Is it clear the whole concept of abstraction?
Yes, teacher.
Okay, now. Now we can move to another concept which is known as static and instance variables. Okay, and we can say methods. So this is again a very important concept. Let's say we have a car here, class car here. In this class, we have a variable here. Okay, a simple variable, wheels. In this wheels, let's say we have this 4 here. Now I'm creating a method here, which is a initializer method. And here I have the cell as a parameter, a brand, and model here. Okay. Now here I can use self dot wheel self dot brand equal brand, and I can use the self dot model equal model here. Okay, that is my class here. Now here, V is known as the static variable. Why? I will explain later. For now, it is a static variable. And this self, brand, and this model, these are known as the instance variables. Okay. For example, let's say I'm creating, let me write here, these are like instance variable. Now let's say, now I just wanted to create a class here, like an object here. So we can use car1 equal, we can call car as a class here, and then I can provide brand and model. Now what is brand? Sorry, C is in small case. Brand, let's say we can put Tesla, and model we can put, let's say 1.1, so just 1. Okay, let's say we have car number second. Okay, this is my second object. my second reference variable, where I have this car again. Again, I'm calling my class car. And inside car now I'm using a different model here, different name here, different brand here. Let's say Honda. And here,
Mhm.
let's say model is again 1 year, or let's say 3 year. Okay. Now you can see what is instance variable. Instance variable is a variable which can change with the object, which can change with the object. So instance variable is also known as the object variable. Why? Because you can see a brand. Brand is a Tesla here. Okay, and model is 1 year. Now I am creating another object which contains another brand, which is Honda, and model is 3 year, which means this brand and model are changing. This can change with the object. Let's say now I'm creating another object class car 3. Now I can put here another brand here, let's say Toyota. Okay. And here I can put another model here, let's say 4 year or 1 year or any model here. So now you can see this brand and this model are keep on changing with the object. Whenever I'm calling my class, whenever I'm using my class, this object are keep on changing. Okay, if I print, you will see. Sorry, I'll run this print. You can put car one dot brand comma car one dot model. Okay, same as we can do here for the card second and for the card third. So if I run this one, you will notice three different models: Tesla, Honda, and Toyota. Same as brand and model. So these variables are keep on changing. This brand and this model are changing whenever you are creating new object. So these variables are known as instance variable. While wheels is a static variable. This is not changing. See, if I print here, print car, sorry, car one dot wheels. Okay. So if I run this one carbon dot wheels, you can see we have four wheels here. Four. Okay. Now I can run again, print car second dot wheels. Again, you will notice four here. Again, four. So this particular variable, wheels, it is not changing. It is not changing with the object. So this particular variable is known as static variable. Okay. Now static variable is also known as
Mhm.
class variables. Okay. They are also known as class variable. Why? Let me tell you. And this instant variable is also known as object variable. Okay, object variable. For example, let's say, I just wanted to change the value of brand. Okay, so I can change it. I can change it easily. How I can change the value of brand? I can simply put here car one dot brand here, and I can change the value here. Okay, let's say we can put here any value. Name any car. Let's say shift. So this is my value. Okay, now if I run this one, print car one dot brand. Now you will notice a different name here. Okay, which is shift here, which means this value, brand is an instance variable, and we can change this value by calling the car one. Car one is my object here. So that is why these variables are known as object variables. Whether you wanted to call them or whether you wanted to modify them, you have to call the object name here. Car one dot model, car one dot brand, car two dot brand, and so on. So whenever you are calling the instance variable, you have to call with the help of object, car one dot object. While this wheels, wheels is a static variable here. If I wanted to call the wheel, I can also call with the help of car. Car is my class name. Okay, so what I can do, I can also print here car dot wheels. I can do this. If you see, you will see a 4 here, which means if I wanted to call this wheels, I can call by using the class name. That is why these objects are known as class
Mhm.
variables. These variables are known as class variables. While the variables which you are calling with the help of object, like car one dot brand, car two dot brand, they are you are calling by the help of object name. Car one is object, car two is object. So that variable is known as object variable. And if you wanted to modify them also, you have to modify with the help of car one only, like the object name only. If you wanted to modify the car two, you can put car two dot brand. and you can change the value here. So whenever you are modifying the instance variable or you are calling them, you have to call with the help of object name here. Car1, car2, car3 is my object name. While the static variable first, they remain the same. They are not keep on changing. Instance variable are keep on changing with the objects. Wheels will not changing because it is a static variable, or we can say class variable. If I wanted to change the value of the wheels, how I can change it? I can simply use car dot wheels here, and wheels is 8 here, let's see. And if I run this one, you will notice 8 here, 8. Which means if I wanted to modify the wheels is a static variable. I have to call it with the name of car. Car is my class here. Okay, car is my class here. If I wanted to print, I have to print with the name of car. Car is my class here. So the static object is, that is why it is known as class variable, because you are calling them or modifying them with the help of car class here. While the instance variable are known as the object variable because you are calling them or modifying them with the help of object name. Car1, car2, and car3. And instance variable is like keep on changing with the objects. The more object you will create, the instance variable will keep on changing. For example,
Mhm.
Tesla here, Honda here, Toyota, it is keep on changing. Brand is keep on changing, model is keep on changing. That is why they are known as instance variable. And the variable which is fixed by nature is known as static variable, and which we can
Mhm.
access with the help of class name here. While instance variable can be accessed with the only with the help of object name. Okay, like we cannot do this car dot brand. This will throw the error. Okay, so we cannot call that. But we can call the instance variable with the help of car1 dot brand, like this one. That we can do. Okay, so that is like the major difference between the static variable and the instance variable.
Mhm.
Is it clear?
Yes, teacher.
So these, even if I create another variable here, let's say color equal white. Okay, color white is my color is a static variable here. Static variable, which is also known as class variable. So if I wanted to access the static variable, which is color, I can access with the help of car. Car is my class name. Okay, car is my class name. Or if I wanted to modify the color here, I can modify with the help of car dot color. Okay, car dot color. If I create another instance variable here, let's say we can put here, what's that, let's say, or let's say price. Okay. Price is my another instance variable here. So I can put here sell dot price equal price here. Now this price is also keep on changing with the objects. Let's say here the price is, you can put, let's say 10 LPA, okay, like 10 lakh, or we can put here 50, or here we can put something, here we can put 10 million or anything, any number we can put here, let's say 20, so on. So these prices are also changing, 10, 15, 20. So they are also changing with the objects. So that is why prices are instance variable, and static variable are these variables, wheels and color. So this is an important concept in the OOPS. What is a static variable and what is a like instance variable. So variable which are changing with the objects are known as instance, and the variable which are fixed in nature is known as static variable. Fixed in nature means we can change them. If you want to change the color, how we can change? Then you have to call the class name, not object name. Car is my class name dot color,
Palo.
and I can change the color red. Let's say. So
Mhm.
this is how we can modify it. Okay. While if you wanted to modify the brand, model, or price, you have to call them with the object name. Car1 is my object name, brand, and this is my brand here. Okay. So this is a concept of static and instance variables. I hope this much is clear.
Yes, teacher.
These concepts are a little bit of complex. So if you watch the video again, you will like, and if you practice on these code, you will get the
Mhm.
idea. Now,
Yes, teacher.
next concept is data hiding. Data hiding. Let's say, let's say you are a senior programmer, okay, and you have created a class here. Let's say class name is solution here. Okay, we have created a class solution. And here you are using a, let's say, what we can, you are using a variable here, a static variable private counter equal 0. Okay, now you have can create a class sum, and here we can use self. And here in this we can, let's say, we can use self dot private counter plus 1. And then we can print self dot private. Okay, this is my solution. This is my simple class which contain a class name is solution and which contain a static variable which is private counter. Okay, a simple variable, and then we have a method here which is sum. It will sum all the numbers, like it will sum and keep on incrementing the private counter by 1. Okay, and if I run this one, let's say count equal solution. So this is my object here. Now if I run this one count dot sum, let's see what will happen. You will get 1 here. Why? Because the private counter value is 0. And we have incremented the private counter, which is this one, by 1. So 0 plus 1, 1 here. Okay, that is like a simple program. Now let's say your private counter, you have created a program. Let's say you are a senior programmer, and this private counter is like kind of very confidential, or we can say important variable here. And you don't want it to access, you don't want that your junior programmers can access this private counter. Okay, means you wanted to keep this particular private counter as a private counter, like a private variable. Like no one can access this private counter outside of the class that you wanted. Okay, like no one can access this private counter, or like access means, or no one can change the value of this private counter without your permission. Okay, means you wanted to make this as a private counter. Okay, like a private variable. So you can make this by using double underscore here. Okay, double underscore. Now this particular variable is become a private variable. You can see private underscore counter is not accessed. Like we cannot access. So this is my private counter here, like my private variable. So this is the counter. I'm using this counter here also. So I can print here underscore underscore as well. And I can print here underscore underscore as well. Okay. Now you can see inside my class, I have created a private variable. This particular variable is known as private member. Private member. Okay. Why private member? Because I have put double underscore before the variable name. Double underscore means you have made this particular variable a private variable. Like no one can access this private variable outside of the class. Okay. Like no one can modify its value and no one can access this variable. See, if I run this program again, we have this count solution here. Okay. Now, if I sum this one, you will see an error here. Okay. No error. It is okay. Let's say no. Let's not run this counter. Let's run this print self. Sorry, count dot private count. Okay, let's do this. So now I just wanted to access the value of the private counter. So I can put count. Okay, and this private count. So if I run this one, you will see an error here, which is solution object has no attribute private counter, because private counter is now a private variable. No one can access outside of the class. Even if you see this one, this is my simple variable. Okay, inside this one, I have put a double underscore. So this becomes my private member. If I remove this underscore from here, okay, if I remove my underscore from here, now you will see an error here, which means a private member cannot be accessed within the class until you put double underscore. If I run this one, you will see an error here. But if I put double underscore here, which means I am accessing the private member within this class solution. Same as I can use double underscore here. Now I just wanted to access the private counter from this class. So if I run this one, again you will see the error, because here I cannot access the private counter. within the class because it is a private member. But what if I put here underscore, like double underscore? Let's see. Now you can see again we have the error. Now you can see we are using double underscore also here also. So why it is not printing? Why it is not printing the output? Because it becomes a private member. It becomes a private member. I cannot access this private counter outside of my class.
Mm.
Okay, I cannot access. And that particular concept is known as data hiding, where we are hiding a particular mechanism inside the class so that no one can access that particular attribute or method outside of the function. Even we can make this function a private method also, like by putting underscore underscore. I can put underscore underscore. Now this method is become a private method. Okay, so if I run this one, count dot underscore underscore sum, this will throw the error here. See, this will throw the error. If I remove this private counter from here, see, solution object
Yeah.
has no attribute sum, which means now this one is also a private member. Private member, we can say private method, which means I cannot access this particular method. Even I cannot access this particular variable outside of my class. Okay, I cannot. So this is known as data hiding. Whenever you are hiding some part of your class, like some attributes or some methods inside your class as a you are using as a private member. That particular
Mm-hmm.
concept is known as data hiding. Okay, which is all written here, the definition. Data hiding is a concept which underlines the hiding of data or information from the user. It is one of the key aspects of the OOPS strategies. It includes object details such as data members, internal work, etc. Hiding exclude full data entry to class members and defend object integrity by preventing unintended change. Which means now I cannot even access the private counter because it is a private member. I cannot access the sum here because it is a private member. Okay. So this is like a kind of a private members here. I cannot change them. I cannot print them. I cannot access them. They're like data hide. Okay.
Mm-hmm.
Now, most of the cases, when you see the actual coding, actual like software programs, you will see this class will be on the second file, and this object will be in the first file. Okay, like first file and second file. Like this class will be a module in the second file, and whenever you wanted to access this class, you will create a new file, and you will create object count. Inside count, you will see solution here, and then you cannot access. For example, let's say I am creating a new file here. Okay, for example, I'm creating a new file. In this file, I'm putting this class here. Here.
Mm-hmm.
Okay, now let's say demo.py. Let's say my file name is demo.py. Now inside this file, I have my class implementation here. Inside that also, I am creating a simple function, okay, without private member. So my simple function is function, which will take self as a parameter, and this will going to print hello world. See, whenever you do real-time programming, this is the mechanism only. The main code is hidden from the programmers, even from the programmers. Let's say you are a senior programmer. You have coded these line, and you have hide this file. You have put the code in one file, and you are not showing this one file to any other user, not even the programmers, other programmers. And you have asked your junior programmer to implement some part from this some part of this class solution as an object here. So you have import the demo here, demo as a class here. Okay, so now here we can use demo dot solution. Okay, demo is my file name, demo, and demo dot solution. Solution is my class name here, and I'm storing the solution inside my object here. Now, if I run this one, you will see no error here. Okay. Now, let's say I just wanted to access some features, so like some attributes, we can say, or some method from the solution. And let's say this code is hidden from me. I don't know this code. Okay, I just know that there's a class name solution and I can access some features. Now, if I show you, if I like right here, count dot. Okay. And if I try to access the function, then that is okay. That I can access. Hello world. But if I try to access anything apart from function, let's say private count, private count, or let's say underscore underscore private count.
It's hide.
We have this error here. And if I try to
Mm.
access that sum function here, sum, that will again give me the error, which means I cannot access some of the methods and some of the attributes from the class solution, that I cannot access because they are like
Mm.
private memory. Okay. So this concept is known as data hiding. Is it clear?
Yes, teacher.
Okay. And this one more thing I just wanted to clear out. In the data hiding, actually we are hiding the methods, or we can say the attributes, we are hiding them. But actually in the Python, there's nothing hiding at all. Why? See, if I run this program, now what is happening here? Like what is happening? When I am using this underscore underscore private counter, what is happening? So when I am running this code, this one, underscore underscore private counter, this name is changing into any other name. That is what it is hiding. Like here, this particular name is changed to any other name, which means this name is converted into underscore solution underscore underscore private counter, which means this hiding, how this hiding is working. When you hide this program, this hide, whenever you are making this variable private, this variable is actually not private. This variable is changing its name. And the new name is underscore solution. What is solution here? The class name. Underscore solution, underscore underscore private name. That is the actual name of the private counter now. So if I write here, print underscore solution and underscore underscore private counter, this will going to print the output. Actually, this will going to print, see, 0. It is printing 0. Even I can access this sum here. The sum is, if I print here, or if I call count dot underscore solution here, underscore underscore sum. Okay. Now I'm calling this one, this sum here. So this will going to run. This will going to run. You can see. This is running 1. So what is actually hiding here? So in the Python, there's nothing as hiding the functions, or there's nothing as hiding anything. You cannot actually hide anything in the Python. That is why here we can access this private member. And why we cannot hide anything? Because this one saying in the Python is mainly for the adult. Python is mainly for the adult here. Means we cannot truly hide anything in the Python. Anyone can see anything, like the developers can see their own code. So there's nothing truly hiding. If you are coding in Java, then you can use this private as a keyword to hide the variables. That is a true hiding in the Java language. But in the Python, there's nothing truly hidden. So that is why you can access this private counter. And now you can see the difference. This private counter, when I use underscore underscore here, the name changed to this name, underscore solution, which is the class name, underscore underscore private counter, which is we are not actually hiding, we are just converting this name into this name. So whenever I
Mhm.
ask with underscore underscore private counter, there's no such name because the name has changed to this name. So that is why I just call this name here and I just print the output here, 101. So everything is working. You can even modify these one. So actually, this is not truly hiding. I just wanted to tell that. So why we have this concept of private member? See, let's say you are a senior programmer. You are creating something. You are creating an application, and you have marked this packet as private member. Like you have put underscore underscore private count. So you are telling some other programmers, your junior programmers, that this particular member is a private member. So do not touch it. Means your junior programmers can touch it, but you are telling them to not to touch. So that is like a, that's why we can see you have to be a better understanding with your developers so that they cannot touch your private members. Okay, they cannot modify your private members. That is what the private that is what the Python is. Python is mainly for the adult. Okay, if you are telling your junior programmers to not to touch your private members, so they will not going to touch. But actually they can change, they can modify, but you are telling them, you are just marking them that it is a private member, so do not touch. So now they will not going to touch. It is like, it is all about understanding. If you have a better
Mhm.
understanding between your developers, then they will not touch. If someone wanted to take revenge from you, then they can modify your program. They can modify your private member easily by using this syntax here. But if you have a better understanding within your junior programmers, then between your junior programmers, then they will not going to touch your private member. So that is why the whole concept of data hiding is a illusion here. We can actually change the variables, we can modify it, we can access it. But why flagging as private member, you are telling everyone that do not touch this particular member. It is a private member.
Mm-hmm.
Is it clear? The
Yes,
concept.
teacher. Mm-hmm.
So this is known as data hiding, which is not actually the data hiding, illusion of data hiding, but yeah, this is a private map. So this is a private attribute and this is a private method here. And we can,
Yeah.
if you wanted to access the private member, then we can access with the help of this particular syntax. Underscore solution, which is your class name, underscore private counter, which is a variable. Same as with this. Okay. The next concept which we have is encapsulation. Encapsulation is again a kind of a concept we can say contain the data hiding concept. Like data hiding comes under encapsulation. So let's see. Since inside encapsulation, what is encapsulation? Encapsulation is you are encapsulating, or we can say you are just like your class containing many methods, or we can say many attributes. That is all about encapsulation. Like you are putting many methods and programs inside your method. So
Mm-hmm.
encapsulation, class. Encapsulation is one of the fundamental concept in the OOPS. It describes the idea of wrapping data. Like you are wrapping data means you are wrapping the methods, you are wrapping the that attributes and the methods that work on data within one unit. So this put restrictions on accessing variables and method directly and can prevent the accidental modification of data, which means inside and encapsulation we have also data hiding also. So data hiding is the part of encapsulation. Okay, so
Mm-hmm.
how this encapsulation work? Inside encapsulation, we have two types of variables, like two types of members. We have protected members and we have private members. Private member is like the member which we have just discussed. We can create private member by using underscore, which means these are the private members. Then we have protected members. Now, what is the difference in the private member and protected member? Private member, by definition, is we cannot access the private member, we cannot modify them. Okay, within the class or
Mm-hmm.
outside of the class. But protected member can be changed. It can be modified. It can be accessed even outside of the class. That is what protected member is. So protected members in like in C++ or Java are those members of the class that cannot be accessed outside of the class and but can be accessed from within the class and its subclass. To accomplish this in Python, we have to follow a syntax which is putting an underscore, which means you can see protected member are the member which you can change or modify or access within the class, not outside of the class. Private members are the members which you cannot even access inside of the class, or we can say inside of the same class or outside of the class. But actually we can. Okay, but actually we can. So that is like a you know a illusion that we are actually hiding the data. We are not hiding it. But protected member is like some part of the data encapsulation. So let's see this example, like a very simple example. In this, we have a concept of let me copy this.
Mm-hmm.
See, here we have this code here. Now, how we can create a protected member? See, this one is by class base. Okay, inside this class, I have an initializer, and inside this one, I have two variables here, A and C. Inside this, we have written hello world. And inside C is a private member. You can see C is a private member. This is the code of private, not protected. So this is the code of a protected member. So again, here we have this class base. Inside this class, we have an initializer here. which is self.a. Okay. Now self._a. Why putting a underscore before your variable name is a making it as a protected member. Why putting double underscore is a private member. Why putting single underscore is a protected member. So this single underscore is a protected member here. Underscore a is a protected member here because we are putting underscore before your a. Now we are creating another class which is a child class, and that is a derived class, and that is deriving from the base class. So base class is a parent class, derived class is a
Mhm.
child class. Here we are initializing the variable self. Now here we are calling constructor of the base class, which means here we are calling base dot underscore init, which means we are calling child like parent class as a base class here, base dot initializing self here. And what we are initializing? We are initializing, we are printing the self dot a, means we are printing the protected member. Now you can see we are accessing the protected member. We are actually accessing the protected member within the subclass, which is self underscore a. Even we are modifying the protected variable here, which is self dot underscore a is 3. Previously it was 2, now it is 3. So we are actually modifying it. We are actually accessing the protected member. Okay, now I'm just creating the two objects, which is object 1 is derived, object 2 is base class. And now I'm just printing this derived class dot this one. I'm just calling the derived class, just object 1 dot underscore a, and this is after modification. Okay, so this is object 1 dot a. If I run this, I see. For now, I'm just removing this part, and I'm running object 1, which is a derive dot underscore a. Okay. So if I run this one, you will notice three parts here. First, calling the protected member of the base class 2. So this line is printing. Calling the protected member of base class 2. And here we are using an initializer here. Initializer means this will automatically initialize. And here you can see we are initializing from the base class, which means first this line is printing.
I see.
Just a second. Let me run this again. Yeah, first this line is printing, which is calling protected member of base class 2 here. Then we are changing the variable, which is changing the protected variable 3. Now it becomes 3 here. Okay, which is calling the modified protected member outside classes 3. And then what we are doing here, we are running this code. After this object 1, where I run this object 1, here you can see this line is also printing, which is accessing the protected member of object 1 is 3, which means first I call my first I created my class and I have just stored this class inside my object. Okay. So now we are just, when I see, if I remove this part, you will see two more lines, just two lines, which is these lines, because here I'm using an initializer here. Initializer is, it is automatically run. Okay, when I create my object. So these two lines are running here. So this is before modification and this is after modification. Overall, I just wanted to show you that we can access the protected member outside of the class also, and we can also modify the protected member outside of the class, because this is my subclass and my protected member is in my parent class. So what I'm doing, I'm just like inherits from the base class,
Mhm.
and then I'm changing, like I'm accessing the variable which is protected variable, and then I'm changing it. Then I'm just
Mhm.
printing this line, which is print the accessing the protected member of object 1, which is a derived class, object 1. So this will run 3 here. Now the new value of your object 1 is, which is your A is 3 here, because we have modified it here. But if I run the object 2, what is object 2 here? Object 2 is your base class. Base class. If I run this one, you will notice the value of object 2 is again 2 only. Sorry, A is 2 only. Okay. So means the previous value of object of A is 2 only. Okay.
Mhm.
But we have modified this value in my subclass, in the derived class. It is like kind of confusing. I just wanted to show you the concept of protected member. Protected member is a member which we can modify it and we can access it even like within the class and even in the subclasses. Okay, in the child classes also. while private members are the members which we cannot access or modify outside of the class or even within the class or subclasses. That is the whole concept of data encapsulation, where we have the protected members and private members. Okay, and data encapsulation is it is putting all these variables, protected member, private members, methods, attributes in one single class. That's why it is like encapsulating everything. Okay, that is like a encapsulation concept here. We are putting everything in one class, like the protected member, the private member, so that no one can access a private member from your class. So that is a concept of protected member. Private member is same, which is here if I just copy this code of the private members. Private member is same as data hiding. Like data hiding, you can see is the part of encapsulation as a whole. Okay, so this is the example of protected member and this is private member. In this private member, I have this class base. Inside this class, I have initializer as a function here. Okay, like a method here. Then we have the self.a. Inside self.a, I have this hello world. Inside this one, I have this hello world. Then this self.a is a simple variable. It is not a protected variable or a private variable. But this C is a private variable. It means a private member, which is printing, let's say, hello universe. Okay. So this underscore C is a private member and it is printing, it is containing hello universe. Then I have created a class, which is a derived class, and we are deriving from the base class, you can see. And we are calling base dot initializer here. And now you can see what we are printing here. We are printing the calling private member of the base class self dot underscore C. Means I am accessing my underscore C like private member in the subclass, in the child class. Now what I'm doing here, I'm just writing object one dot base and then I'm printing object one dot a here. What is a hello world? So this will print hello world here. So this will print without error hello world. Now let's say I'm creating object number second for my derived class. Okay, for my second class, my subclass. So this is my derived class here. Object 2 containing derived class. Now see, if I just wanted to access, if I wanted to access object 2 dot a, what is a here? A is this variable. Okay, now I can access this a because it will print hello world. Okay, there's an error here. Let me remove this part first. Yeah, so we have this derive here and we are calling this a here. Okay, now see, if I run this one, you will see an error here. Now, why this error is coming? See, this error is coming from this derived class. What I wanted to do, I am accessing this self dot underscore C within the subclass, within the child class. And you can see we cannot access that particular attribute. Why? Because it is a private member. It is a private member. I cannot access. So this is what I would just wanted to say. Protected member is like a member which you can access within the class and even outside of the class within the child classes. But private member is a member which you can not even access in the child classes. So that's why this error is coming. We cannot access this particular member within the child class because it is a private member. But again, private member is a myth here. It is a myth here. We can access this underscore C by putting underscore base here. This is how we can access. Now it will not going to throw the error. If I run this one, you will notice hello universe. Hello universe is coming from underscore C. So all I wanted to say is like private member is a concept, but it is a kind of a myth in the Python that we cannot truly hide anything. We cannot. Okay, it is like it is on the developer understanding. Even you will see some developer who are thinking that private members are totally private. Like we cannot change it. But now you know that we can change it by using this syntax here. Okay, everyone is not aware about the syntax that how we can access the private member if it is private, but you know the syntax. Okay. So this is what I wanted to say. Private member, like private or hiding, is a myth in the Python. We cannot truly hide anything.
Mm-hmm.
The concept of data encapsulation. We are using protected member, private member, everything. If I create a protected member here, see self dot b here underscore b equal, let's say hello earth. Now underscore b. This is a protected member because we are using single underscore. It is a protected member. And if I use underscore c, it is a private member. Okay, and this is a normal member. Okay, like normal member. Now, what is protected member? I can access this protected member within the subclasses. Okay, like if I wanted to print here, print self dot underscore b, then I can access it because we can access the protected member within the subclass, but we cannot access the private member even within the subclasses. That is why it is too private. And you can see hello earth is printing here. But again, private member can be accessed by using the syntax. Underscore base is the
Mm-hmm.
class of that particular like variable, and then underscore c. Totally what we are doing, the Python is what Python is doing. Python is just changing this name underscore c to any other name, which is this name. And we have to write the same name to access that element. Okay. What others are thinking that the Python is actually making it private in the backend. But actually Python is not making anything private. Python is just changing its name and not showing that name. But if you do some research, you will find this name easily. That whenever you wanted to access the private member, you can use underscore the class name of that private member underscore c. So Python is not actually hiding. Python is just changing this name to this name. And whenever you
Mm-hmm.
wanted to access this name, you have to write the exact name, which is this name for this underscore c. But this name is actually hidden from the user. Okay, this name is hidden from the user. But if you do some research, you will find this name. It's not
Mm-hmm.
a big deal. Is it clear? The concept?
Yes, teacher. Yes, teacher.
I know it is a little bit of hectic and complex.
Mhm.
So this is our last topic, which is
Yes,
data
teacher.
encapsulation. Let's see if we can continue. Yeah, we have one more concept which is known as getter and setter. So let's cover that also.
Mm-hmm.
Now we have this private member. Private member cannot be accessed. Let's say let's create a program here. Simple. Here we can understand about getter and setter. Let's say we have a class first. In this class, sorry, this is not class. Then here we have this one underscore edit. This will take self as a parameter and then name and then age. A simple class. Then here we can use self dot name equal name, and we can use self dot age equal age. Okay. Now what I'm doing, I'm making this name and age as a private members. Okay. Now these are now private members.
Under
Name.
the underscore.
Now name and age are the private members.
Mm-hmm.
So let's say I'm creating a P equal object here with the named person, and I'm providing names here. Let's say John, and age is 50. Now I just wanted to print P dot underscore name. Now I cannot print because name is a private member. If I run this one, you will see the error here. Okay.
Mm-hmm.
But how can I access the private member that you and me is no we know very well. I can put underscore and person.
A person. Yeah.
So this is how we can access. But let's
Yes,
say there's
teacher.
another developer. What is the another way of accessing? You can see this is a hack here. It is a hack. Now you know the
Mm-hmm.
hack of accessing the private member. But what if you wanted to go to a legal way, like to a straight way, like how we can access? So that we can use getter and setter. Getter is a function. It is a simple method. Let's create a getter first. How we can create? We can simply use get underscore name and then self. And then here we can return self.name. Now this is known as a getter here. Now what is this getter? See what is happening here. We have this class person. Inside class I have two methods. Sorry, yeah, two methods. First
Okay.
method is initializer. Second method is get name. This is also known as getter. Getter is just a concept. It is just a simple method here. Inside my initializer function, I have two variables, which is name and age, which are private member. What are private member? Private member cannot be accessed in the child classes or outside of the function, but they can access within the class. So what I am doing, I am creating another method, which is get underscore name. And that get underscore name is accessing the name here, this name. Means this get underscore name is accessing the private member within the class only. That is possible. Okay, now what I can do, I can use this get underscore name as a function to print the name here. That I can do. Okay, so what I can do here, I can use here p dot get underscore name. Now this will print John. Sorry, I have to use parenthesis here. Then this will print John here. Okay, means this is known as getter. When you have any private method and you wanted to give the access to access the name of the method, then you can use getter. And when you wanted to set or modify the private member, then you can use setter. How you can use setter? You can simply use def set underscore name. Okay, and self dot. It will take name as a parameter which you wanted to change. And then we are providing self underscore name dot name. This is known as setter. Now let's say I just wanted to change the name John to any other name. So I can change it. So I can put here set underscore name and I can print a parameter. Let's say my name is Bhav. I can put it. So if I run this one, you will notice Bhavya in place of John. Okay. So that is yeah. So that is a setter here. So what is getter and setter? Again, when we have any private member inside of a class and I just wanted to give the access to access my private member, then I can use
Mm-hmm.
getter and setter. If I wanted to give the access to print the private member or to access the private member, I can use get name. If I wanted to give the access to change the private member, then I can use setter here. So the getter and
Mm-hmm.
setter is specially used with the private member only because we cannot change private member, right? At least we cannot change without hacking it. Okay, so we
Mm-hmm.
cannot change the private member. Even we cannot access the private member. So that is why we have this different way of getting, like changing the private member and printing the private member. Same as we can do with the help of age here. So let me copy this and we can print here. So in place of name here, we can use age here. Get name and sorry, get underscore
Yes.
age, set underscore age. Here we
Mm-hmm.
can use age and here we can use age and age here and age here. Now this is the getter and setter for the age. Okay, for the age member, and this is the getter and setter for the name here. Now what
Mm-hmm.
we can do? Now name and age I know is my private member, but I am providing the access to access my name and age and changing my name and age. So I can use here the same syntax. Okay, we can set age and we can get age. So I can change the age and I can print in the age. Okay, you can see
Mm.
why it is printing. We don't want to print it. I don't remember this part. We're just getting it. So again, we are not printing the name. We're just changing it. Now you notice.
There you
Okay,
go.
so we have changed
Come.
the name
Mm-hmm.
and the age. And if you wanted to apply the hack, then you can simply use underscore the class name, which is person, and underscore the name.
Mm-hmm.
Okay, this is another way. This is like an actual hack, but we are not following this one because we
Right.
are a developer. So this is known as getter and setter concept.
Mm-hmm.
Getter and setter are just a simple method only, like other methods, but they are accessing the private member. They are accessing the private member. That is why they are known as getter and setter. Getter is mainly for getting, or we can say accessing the private member within the same class, and setter is mainly for setting the different value or modifying the different value of the private member within the same class. Okay, but you cannot do this in the subclasses. That is not possible, because private members are the members which you can access or modify within the same class, not in the child classes. While protected member are the member which you can change or modify, or we can say access within the subclasses also. Okay, not
Okay.
within the child class also. That is the main difference in the private members and protected member. And they are all the concept of data encapsulation. And
Okay.
data hiding is also the concept of data encapsulation.
Okay.
Is it clear, this
Yes,
concept?
teacher. Yes, teacher. Clear. That's good.
So this is like a little bit of complex, but once you practice it, you will get the answer. Okay.
Yes, teacher.
So we are left with some more concept of the OOPS, like decorators, generators, that we will discuss tomorrow.
Yes,
Okay.
teacher. Thank
One
you
more
very
thing,
much.
and one more thing I just wanted to explain,
Mm-hmm.
that this one underscore init is known as the constructor, or we can say this is also known as magic methods. Okay, so that
Oh,
I just forget to mention. This underscore init is known as
hiding.
the magic method.
Magic.
Magic method. Why it is known as magic method? Like, what
Mm-hmm.
is the reason behind it? So let's say I have this class person, and here we are just initializing def underscore init underscore. Let's say it will take self name age, and then with self dot name and self dot age. Now this init underscore init, it is also known as constructor, or it is also known as magic method. Why it is known as magic method? Because basically it is a simple method, but it contains a superpower. And what is the superpower? It can be initialized without actually calling the function that we have discussed, right? For example, if we have this function, def function, like this one. So this function needed to be called. We have to call this function. Okay, we have to call. We have to call this function. Okay, then only we can use this function. But underscore init, it has a superpower, which is it can be run without calling it. That is why this method is known as the magic method. Even this method, which is def underscore str underscore. This is also known as a magic method. Okay,
Mm.
why? See, whatever you find, whenever you find this particular syntax, underscore name, underscore, these all methods are known as magic methods. Means whenever you find a method which is starting with the underscore, ending with the underscore is a magic method. Okay. So that is what I just wanted to share.
Mm-hmm. Thank you very much, teacher. That's interesting.
Any other question from
Not,
from this concept?
not teacher.
Okay. So I have one message for you.
Yes,
I
teacher.
will share this video in within 1 hour, and I will share some questions. Okay, so you can just try it. Okay, and one more thing. Tomorrow we will going to do a project on the OOPS. Okay, we will
Yes,
do
teacher.
a like a fully fledged project on this part only OOPS, so that we can practice all the concept which we have studied in the OOPS. Okay,
Okay, teacher.
so
Teacher, I have only I know this my what do you call this favor, because is it possible on next week, teacher? Can we start again the same schedule?
from 8 to 10.
Oh yes, teacher. Not next week, so that I don't want to change your schedule tomorrow. But if it's okay for you.
Yeah, we can. Tomorrow we can also continue from 8 to 10. No issue.
Oh, thank you, teacher. Thank you. Because I realize it's better. You know, in my time it's 7:30 in the evening in my time, so I can start studying with you, with our class.
Okay, no issue, no issue.
So
Tomorrow
eight,
we can, yeah,
yeah. So tomorrow 8 o'clock in the morning.
yeah, 8 o'clock in the morning, 8 to 10.
Yes,
Yeah.
yes, teacher. 8 to 10. Hey, thank you, teacher.
Yeah. And any other questions?
No, teacher. I need to practice oops.
Okay. And try to practice before morning and before tomorrow's
Yes,
morning, because we are going to do a project. Okay.
there you go. Thank you very much, teacher.
Okay. Yeah. Thank you. I
Thank
will
you.
share the
Bye.
video as soon as possible.
Yes,
Okay.
please. Thank you, teacher. Bye.
Thank you. Bye.